Let's look at this problem. It says the sum of two numbers is 5. Well, if we let x equal the first number, y equal the second number, we can represent that by just x plus y equals 5. Then it says 3 times the first number, which is 3x, plus 2 times the second number, which is 2y, is equal to 13. And this is how we would represent that as another equation. To solve this, we're going to substitute this into this equation by saying x is equal to 5 minus y. So when we do, this equation here becomes 3 times 5 minus y plus 2y is equal to 13. When we solve for that, we get that y is equal to 2. And then if we substitute y equals 2 back into the first equation, we get that x is equal to 3. If we substitute it back into our first equation, 3 plus 2 does indeed equal 5. Substituting it back into the second equation here, 3 times 3 is 9, plus 2 times 2 is 4. 9 and 4 is indeed 13. So this is our solution. Now these two equations, x plus y equals 5, and 3x plus 2y are called linear equations. Let's take a look at two integer lines. This one x, which is horizontal, that starts at 0 and goes all the way up to positive infinity to the right and negative infinity to the left here. And at the same time, we're going to add another integer line called y that again starts at 0 and goes to positive infinity in this direction and goes to negative infinity in this direction. And they're at right angles or at 90 degrees to each other. What we can do is take our first equation, which is x plus y, and find out all values of x and y that will add up to 5. So 0 plus 5 adds up to 5, 1 and 4 adds up to 5, 2 and 3 adds up to 5, down to 5 plus 0 is 5, 6 and negative 1 add up to 5. We can also do the same thing for our other equation here. Well, this was equation 1. So for equation 2, we can do the same thing. 3x plus 2y equals 13. So we start off with 1 here. 3 times 1 is 3. 3 subtract from 13 is 10. 2 goes into 10 5 times, and we get our other value. If we use 3 here, 3 times 3 is 9. 9 from this is going to give us 4. 4 divided by 2 is 2. And we can validate that all of these numbers here work by substituting in these numbers to get 13. If we plot our x plus y here, and we've done it in green here, and connect up our dots, we can see that the x plus y line here is a straight line that goes through those points. We can also at the same time plot the 3x plus 2y line in a slightly off color red color here, and if we plot these, we can see that both of these lines intersect, strange enough, at 3, 2. And if you remember from before, x was 3 and y was 2. What we have here is a system of linear equations, and what we have is two equations and two unknowns, and there's an easy way to solve this. Let's take this equation down here and multiply both sides by 3. So that'd be 3 times x plus y equals 3 times 5. And this will give us 3x plus 3y equals 15. Now if we take this other equation down here, 3x plus 2y equals 13, we can subtract these two. So 3x minus 3x is 0, 3y minus 2y is just y, 15 minus 13 is 2, and right away we have our solution for y. And to solve for x, we just again say x plus 2 equals 5, x is equal to 3. So this is a way of solving two equations and two unknowns very quickly by multiplying to make terms the same here, canceling them out, and then solving this. A linear equation is an equation for a straight line. Linear itself means line. And a linear equation is an equation of the first degree, which means the highest power of the variable is 1. So something like x plus y equals 5 is a linear equation. Same as 3x plus 2y equals 13. Both of these are linear equations, and as we saw earlier, they form a line. So far we've dealt with equations with one unknown. We had something like 3x plus 5 equals 20, and we solved it by subtracting 5 from 20. 3x is equal to 15, x is equal to 5. That was pretty straightforward. However, when we start dealing with equations and two unknowns, this becomes a little different. Let's take a look at example 2. And this is an equation in two unknowns. We have 2x minus y equals 3. Now we can easily rewrite this into this format here where y equals 2x minus 3. Then we can substitute in values for x like 3 into here. So 2 times 3 is 6 minus 3 is 3. We can then substitute in 2 times 2 is 4 minus 3 is 1. And so on. We can fill out this table, and basically what we can do is come up with a graph where we have a straight line, a linear line here with all these points plotted, and this is part of how we would do a graphical solution for finding two linear equations and two unknowns. Now this is our original equation, 2x minus y equals 3, but if we wanted to solve two linear equations and two unknowns, let's assume we've got another one, such as 3x plus y equals 7. Now we've already seen the plot for this one, and if we were to plot similarly this one, 3x plus y equals 7, we would definitely get this plot. Now where these two intersect is going to be the solution for these two linear equations. And the solution here is going to be at 2 and 1. And we can see that this is going to be our x, which is 2, and 1 is going to be our y. And we can substitute this into an algebraic form and work it out differently and see that indeed we do get the same answer of 2 and 1 is the solution for these two linear equations in two unknowns. So let's take a look at this as equation 1 and this is equation 2. Now if we were to add these directly, 3 plus 2 is 5x, y plus minus y is 0, equals 7 plus 3 is 10. Therefore x is going to be 10 over 5, so x is going to equal 2. Substituting this back in to equation number 1, we could have 3 times 2 plus y equals 7, and this is going to be y equals 7 minus 6, so y is equal to 1. And that's exactly the same solution that we got graphically. When two linear equations intersect in a single point, the coordinates of that point, in this case here, will satisfy both equations. And when that happens, these equations are said to be consistent and independent. When two linear equations create lines that coincide at every point, it's really the same line drawn twice. If we take a look at this first equation and compare it to the second one, if we multiply the first equation by 3, we get exactly this, which means we have two lines that are completely on top of each other. Even though they're called consistent, they're dependent because they're all points of intersection. When lines are parallel, they can never cross. What that means, there's no coordinates that satisfy both equations, which means there's no solution. When that happens, these equations are called inconsistent. If we were to actually subtract these two over here, we get 0 equals 2, where there's no variables involved in here, and we know that this is not true. And this is what you get when you have parallel lines in that kind of solution. Sometimes when you see two equations, just by adding these two together, you can see that these two terms drop out and we get 4x equals 4, so x equals 1, and that's pretty easy to solve. In the case of example 9, we have to multiply this equation here by 3 to get common terms. And once we do that, we can very easily come up with a solution. Let's take a look at equation 1 and equation 2 here. We can see that there's no easy way to multiply one of these equations to cancel out either the x or the y. So what we can do is take a look at, say, the 4y and the 3. And what we can do very easily is multiply this by 4 and multiply this by 3. And when we do, we're going to get this equation for this one and this equation for this one, because 4 times 3 will give us 12. And we can cancel out the 12s here and get that 41x is equal to 82 and x is equal to 2. Now sometimes, as in example 11, you're going to solve for x and y, where these numbers in equation 1 and equation 2 are approximate numbers. If we want to get rid of the y, for instance, we can multiply this by 2.61, and we can multiply this by minus 8.47. When we do, this equation here becomes this, and this equation here becomes that, and we see that we can actually add these together and get rid of this y term that's here. When we do, we get minus 9.47x is equal to this number, and therefore x is equal to this value here. If we substitute that value back into the first equation, then we're going to get that y is equal to minus 1.54. And we have to make sure we use our rounding rules, that we have no more than 3 significant digits here and here, because that's what we had in our original. Sometimes we'll find a system of 2 linear equations that have no solution. These look relatively simple. You get basically that these two things cancel out and you got 0 equals 13, which means there's no solution, which means basically you have parallel lines if you were to graph this. So let's take a look at this fractional equation number 1 and number 2, and let's get an idea about how to solve fractional linear equations. Now the one way to get rid of the term here y over 3 is to get a common denominator between the 2 and the 3. The way to do this is multiply through by 1/2 on equation 1 and by 1/3 on equation 2. And when we do, we're going to end up with these two new equations. So this becomes our new equation 1, this becomes our new equation 2. When we add these two terms, what we're going to get is the y plus 6 here and the minus y plus 6 will cancel out. And we're left with x over 4 plus x over 12 equals, and then when we add 5 over 12 plus 7 over 12, we end up with 12 out of 12. Now if we multiply the 4 by 3 here and this by 3, we're going to end up with 3x plus x over 12 equals 1, or 4x over 12 equals 1, or x equals 3, which is our answer here. And once we have x equals 3, all we have to do is substitute it back into our first equation to get what y is. And when we substitute x equals 3 back into our formula, we're going to get y equals minus 2. Let's take a look at how we would go about taking variables that are on the bottom of a fraction in two equations and solving it. First thing to do is have an intermediate variable, such as m, and say that's equal to 1 over x. Also have another intermediate variable called n, which is 1 over y. When you do this, you're going to find that equation 1 now becomes 10m minus 9 over 2n equals 6, and we'll call that equation 1a. Also, equation 2 will now be 20 over 3m plus 15 over n equals 1. And then to make it cancel out with equation 1a, we're going to multiply both sides by 3 over 2. When we do that, we're going to get the following. When we multiply this out, equation 2a becomes equation 2b, so we get 10m plus 45 over 2n equals 3 over 2. And our first 1a is still 10m minus 9 over 2 equals 6. When we subtract these, we'll see that these m's go out, and we're left with 45n plus 9n over 2 equals 3 over 2 minus 6. We're going to see that we get 45n plus 9n equals 3 minus 12, and then when we solve, 54n is minus 9, which means that n is equal to minus 1 over 6. Now if we remember that n was 1 over y, therefore y is 1 over n. So if we flip this over, we get a result of y is equal to minus 6. Now if we substitute y equals minus 6 into our first equation here as minus 6, we end up with this, which can then be rewritten as 10 over x is 6 minus 9/12. And when we do all the math, we find that x is equal to 1.905. And that is how we go about solving equations that have the variables on the bottom of the fraction.